1.8 rational functions and zeros. Here we go.
Let me start at the box or at the top.
Recall.
A rational function is a function that is a ratio of two polynomial functions, take fractions. We explored polynomial inequalities previously, and we can utilize some of these concepts to help us understand more about rational functions like f of x.
Beautiful. Keep going.
Let f of x equals g of x over h of x be a rational function where g of x and h of x have no factors in common.
All right, let's talk about what that means. So if I factor it, and I get like x minus 2 up top, and I get x minus 2 on the denominator, all right? We don't want common factors, okay? That's going to create something else. I'll tell it right now. It's going to create a hole, all right? But this doesn't actually go with this, all right? So if they have common factors, they cause different issues. All right, keep going.
F of x has zeros when g of x equals 0.
All right, so when we have a 0, that means we set what equal to 0? The g of x, which is our numerator. All right, keep going.
F of x is undefined when h of x equals 0.
All right, so when it's undefined, we set what equal to 0?
H of x.
Which is our denominator. All right, call on somebody.
Mary.
Note when solving rational inequalities, we need to identify both the zeros and undefined values. Solving rational inequalities. 1. Make sure that inequality has 0 on the other side. Make sure that f of x equals g of x over h of x. Make sure you have a single rational function.
Good.
Set g of x equals 0 and h of x equals 0 to find values to include on the sign chart. Make sure to factor.
All right, so we're going to make a sign chart just like we did when we went over 1.5. All right, keep going.
Create a sign chart with all the values from step 3. Be careful to mark the values where h of x equals 0 so that we never include those values in our solution. Test values in each interval to see if the values in the interval are blank.
What do you think?
1.
Positive or negative? Now, why can't we have h of x equals 0? It's undefined. We can't divide by 0. Exactly. All right, keep going.
Interpret the sign chart to answer the given inequality. No, be sure to write your answer in interval notation and think about them.
Beautiful. Great job. All right, let's look at our example. All right, so example 1, we have this rational function, and so we're going to find zeros and when things are undefined. All right, and so how do we find zeros? Set our numerator equal to 0. And so when do we get zeros? X equals 2. All right, and so when is it undefined? Okay, so when my denominator is equal to 0. So when is it undefined? At -6 and 3. And so this is where I kind of like differ a little bit. I like to say x cannot equal -6 and x cannot equal 3. All right? Because that kind of explains it, like say, like we cannot have that because we can't divide by 0. Okay? And so now we're going to make our number line just like before. So we're going to make our sign chart. And so I'd test -6 and 2 and 3 here. All right? So let's pick something left of -6. Like what? -7. So when I substitute in -7 right here, what do I get? A negative or a positive? Negative. So I get a negative over a what? Negative and a negative. So a negative is a what? Negative. That's a negative. All right. And so now let's test something between -6 and 2. Like what? I like 0. Whenever I can use 0, I'm going to use it. So this is a 0. And so if I substitute in 0, what do I get? A negative over a positive negative. So what's a negative over a positive negative? That's a positive because it's a negative over a negative. So this is a positive. And so now let's pick something between 2 and 3. Like what? That's what I thought too. Oh my gosh. All right, so now we substitute in 2.5. What's this? Positive over positive negative. So what's that? Negative. All right. And then how about 3? Something right at 3. 4. So this is positive, positive. So what's that? Positive. Look how smart you guys are. And so now let's answer our question. So now it's going to be greater than or equal to 0. So what am I looking for? My positive parts or my negative parts? My positive parts. So it's going to go from -6 to 2. But let's talk about when I can include each. Can I include -6? No, I cannot include -6, so I give it a parenthesis. Why does it get a parenthesis? Why can I not include -6? Because it's undefined there. I'd be dividing by 0 if I included -6. All right. Now, can I include 2? Yes. So how do I show that I include 2? With a bracket. All right. And then my next interval is going to go from 3 to infinity. Now, we can never contain infinity, so that always gets a parenthesis. Can we contain 3? Do I get to include 3? No. Why not? Because it's undefined. Okay, I'd be dividing by 0 again, and we can't do that. All right, let's look at example 2. What does this one not have? This one's not what, Kyler? It's not factored. So what are we going to do, Kyler? Let's F it up. Let's do it. All right, so what's the numerator factor 2? X plus 2 and x minus 2. Beautiful. And what's my denominator factor 2? All right, so what's the denominator factor 2? X minus 5. X minus 5. So I'm going to call it x minus 5 squared. And we want this thing to be less than 0 still. All right, and so when I find my zeros, I set my numerator equal to 0. Remember? And so what is my zeros? X equals what? -2 and x equals +2. And then when is this thing undefined? At x equals 5. All right, so I like to call x cannot equal 5. All right, and so now we're going to make our little number line. And so now I end up having what? -2, 2, and 5. So let's pick something left of -2. Like what? -3. Sounds good. And so what's this part? Negative and a negative over a what? Always positive. So the bottom is always going to be positive. Does everybody follow me? So I got a negative, which is a positive. Why is this freaking out? And then something in between -2 and 2. What do we got? 0. Love it. And so what do we get in the numerator? Positive and a negative. So what's that make it? Negative. Awesome. And so something between 2 and 5. It's like what? 3. So what do we got? Positive and a, which makes it positive. How about something after 5? 6. So what's that going to make it? Positive. All right. So what do we want to do for answering our question? We want this thing to be what? Less than 0. Less than 0. And so now I'm going to go from what? -2 to 2. Does it get to include -2 or 2? No. Why not? Because it's just less than. It's just less than. It's not less than or equal to. It's just less than. So we're going to put what? Parentheses around them. All right. Let's keep moving. All right, so let's look at example 3 now. So now I end up having 2 over x minus 3. And so do I have any zeros on this one? No, I don't have any zeros. However, is it undefined anywhere? Yes. Where? X cannot equal 3. And so on my little number line, I just have 3 going on. That's a really long thing, but whatever. All right. And so let's pick something less than 3. Like what? 0. So if we pick 0, what do we get? A positive over a negative. So what's that going to be? A negative. If we pick something right of 3, like what? 4. So I have a positive over a positive, which makes it a positive. So let's answer our question now. So I want this thing to be greater than 0. So when is it greater than 0? From 3 to infinity. Does it get to include 3? No. Why not? because it would be undefined there. All right, good. All right, I'd like you to try example 4 right now. Help me out. All right, so what are my zeros? X equals -2. Good. All right, when is it undefined? X cannot equal -5, I think she said. All right, and so now let's make our little sign chart. So now we end up having what? -5 and -2. So let's pick something left of -5, like what? -6. So what do I get up top? Negative over a negative, which makes it positive. How about in between -5 and -2? -4, great. So what do I get up top? Negative, positive. So what's that? Negative. And then -2. So like what can I use? 0. I love using 0. So then I get what? Positive and positive, which makes it positive. Now, what am I trying to find? I'm trying to find it less than or equal to 0. And so what am I in between? -5 and -2. Now, can it include -5? No. Why not? It's undefined at -5. Can it include -2? Yes, because it's less than or equal to, and so it is a 0, so that gets a bracket. Pretty good? Cool. Let's do a couple more. And so on this one, we can find our zeros and our undefined real quick. And so what are my zeros on number 5? X equals -2 and 1. Awesome. And so when is this thing undefined? X equals 2. So I like to call it X cannot equal 2. And so now let's make our little number line. And so I'd end up with -2, 1, and 2. All right. So what are we going to substitute in? -3 sounds great. When you're looking at this part's always going to be what? Positive. So I'm not going to enter anything in there. Okay, I'm not going to waste my time. And so this is going to be like -3 minus 1. So this part's what? Negative. This part is negative. So negative is a positive. Awesome. All right, and so -2 to 1. Yes, you guys are so good. All right, and so when we substitute in 0, what do we got? Negative. What's that going to do? That's positive again. And so then 1 to 2. That's what I thought of too. So what do we got up top? Positive and negative. So what's that going to be? Yes, boo. And then how about more than 2? 3. Love it. And so then this is what? This is? All right, cool. And so we made our little number line. Mary's okay. All right, and so then I need to figure out when this thing is greater than or equal to 0. And so what's it go from? -infinity to what? All the way to 1. Why does it get to include -2? Because it's equal to. So everybody's seeing this. All right, so if this were just greater than, I'd actually have to break it up. It'd be -infinity to -2 and then -2 to 1. All right, but because this is equal to, I can include -2, so I can go all the way from -infinity to 1. Now, do I get to include 1? Yes, because that's part of my zeros. All right, so I get to include 1, so I use a bracket. And then I go from what? 2 to infinity. Do we get to include 2? No, so it gets a parenthesis because it's undefined there. All right, let's finish this up for example 6 here. All right, so on this one, what do I get? Undefined at what? 1. All right, so X cannot equal 1. And so this is a quick number line. So pick something left of 1. What do we get? 0. So what do I get there? Positive. How about to the right of 1? What do I get there? Positive. So what am I trying to find? Less than or equal to 0. Can I include 1 on anything? No, because it's undefined. So do we have anything? No. So we have no solutions on this one. All right. That will never be below or equal to my x-axis. All right. And if you think about it, what's its horizontal asymptote? Y equals 0, because and it never gets below it. All right, that's really what's happening here. All right, now let's look at it graphically. All right. All right, Ethan's going to read our directions here.
The graph of a rational function f is shown in the figure above. Use the graph to solve the following inequalities.
All right, fantastic. Part A.
F of x is greater than or f of x is less than or equal to 0.
All right, so f of x implies our what? Our y values, right? And so if it's less than or equal to 0, we're talking about like below my x-axis. So we need to notate, when is this below my x-axis? So when is this function below my x-axis? From what to what? -3. Do I get to include -3? No. So it gets a parenthesis because it has an asymptote right here. It's a vertical asymptote. And then it goes all the way till what? -1. Does it get to include -1? Yes, because it says or equal to 0. Because at -1, it is equal to 0 there. And then when else is f of x below my x-axis, less than or equal to 0? From 2, do I get to include 2? Yes. To what? To 3. Do I get to include 3? No, because it's asymptotical. All right. All right, let's look at B now. So this one says f of x is greater than 0. And so this one says, hey, when is this thing above my x-axis? All right. So when is it above my x-axis? When is it all up here? From what? -infinity, all the way till what? -3. And then it's above right here too. So then from where to where? -1. Do I get to include -1, by the way? I do not get to. Why do I not get to? Because it's greater than, it's not equal to. So I do not get to include -1. And then it goes to what? 2. And then, when else am I above my x-axis? When is f of x greater than 0? From 3 to infinity. All right, and then part C. This one says f of x is greater than or equal to 1. So now, instead of just above my x-axis, I need this thing to be above or equal to 1. All right, and so when is this above or equal to 1? -infinity to -3. And then when? 3 to infinity. All right, it's everything up here. All right.